supply the load. And do you know how many DC load do we have in residential building? Mm. So we have light, yeah, we have television, we have laptop, we have, yeah. You see that, the number of DC loads now is more than the AC loads. So it is much more efficient if we provide DC instead of AC. So we have now this power electronics. So we can easily change from the DC to AC with different levels. So this flexibility problem is not existed anymore. And cost is somehow much more better than AC. Why? Because we don't need to build the transmission and distribution line. So we don't need to pay $80,000 per meter to build this type of new grid. So, and we also can use renewable energy sources for that one, and it can also integrate energy storage. So now we get back to the first question, that if we have a line which can supply power for 500,000. So what can we do? What is the answer? We use the small scale power generation close to the load center. And some of you said that we can use the PV, but with the Edison model also we can use also renewable energy, storage devices, and when the generation is more than load, we can supply the storage, and during the night we can use it. Okay? So this is one solution. So now if we get back to the energy flow in USA, you see that, in 2002, most of the actually electricity are coming from the coal-fired power plant, natural gas, and nuclear power plant. But if you go to 2010, you see that this new generation of the electricity from solar, from wind is increasing, and when we reach to 2016, we see that this share of the this renewable energy increase more and more. So this type of technology are very important for us. Why? Because they are renewable. They don't have any actually limitation for the consumption. They can actually, you can get the electricity for sun, and it doesn't provide any, it is like an unlimited source of energy. It's not like oil and gas. And the other is environmental friendly, and it can actually reduce the greenhouse gas emission. And but they have also some problems. So what is the problem? You cannot predict it. They are not actually constant. They are variable actually. So you cannot provide electricity from wind and say that directly I can connect it to the load, because the speed of the wind is not constant. So you cannot provide the electricity with 50 hertz and 400 volt. This type of problem is appearing. And the other problem, I don't know. So the other problem is that we are using the power electronic converter to provide the electricity from renewable energy sources. This type of actually conversion devices cannot provide kinetic energy, which keep the stability of the grid. So I will come here. Yeah. So when we provide the electricity, then we should provide kinetic energy. Okay, can I touch you? Okay, not very far. Okay, so look at him. Doesn't happen. So you touch me. Look. My inertia is less than his inertia. Is very strong. So thank you. Yeah. So the power that he has is more than me, it means that grid, when we have more inertia, it provides more reliability and stability for the network. So from where it's coming from the rotation, actual shaft of the synchronous generator. But this type of actually power electronic devices cannot provide it. So then we increase the number of the generation, but the inertia of the system will not be provided. And then we say that our grid, after 30% of the generation exceed more than 30 of the actually generation by this type of renewable energy sources, then the system will be somehow unstable. It means that any fault happening or disturbance happening, then grid swing very badly. I mean, the frequency is not actually damping these changes very fast. So we say that our network is low inertia. So low inertia means that it doesn't have enough power to damp the changes. So for this case, this is something that we should consider. Beside that, we need the land which should use. So for example, in the city center of the Warangal, you can make the power plant. So you need the land, and it also provides the damage actually some part of the natural wildlife, and also public health and community is also affected because it makes, for example, wind provide the noises, and they use water, and after life cycle when you actually, it provides some emission. So they have some negative impacts, but what we get is very important because after 5 years, rest of electricity, I mean, the different countries have the different factors, but normally they said that after 5 years, any electricity provided by solar will be free, and you just pay for the maintenance cost. So it is very important that we consider this type of technology for several aspects, but one important thing is that, you know, we can provide electricity without providing greenhouse gas emission. Any questions so far? No? Okay, good. Yes? Mm-hmm. Yeah, of course, we have, we can provide the, for example, wind also. Yeah, in the load side, yeah, it can be also, there is some package that can provide 2 kilowatt power by wind. Yeah. So I'm not sure that I get your question well or not. Yeah, they have actually, but later we see that we have the different size. But the problem with the solar is that you need lots of surface to provide the solar, but you can install it everywhere. But the wind is more power can be generated, but the place that you can install the PV most of the time is not good for the solar. Sorry, for the wind. Yeah. They have actually criteria for provision of the electricity. The limitation is that if you are going to provide the electricity by wind, the speed should be at least 3 meters per second. Yeah. Yeah. I mean, there are lots of limitations. It depends where you are going to install your PV panel, wind turbine. So if you don't have wind, I mean, the first assumption is that you should have the place that have a potential for the wind. So if you don't have wind, it means that there is no make sense actually. But then you can not say that, you know, because we have the torque. And then if we increase the pressure to the shaft, then it will be actually explode. So these type of things are appeared, but basically you cannot, for example, you go to supermarket, you can go by truck and you go by a small Peugeot. Both of them are possible, but truck is not the car to go supermarket. So you should consider that what is the optimum operation for this one. It makes sense for you. But in some cases, for example, if you have a building, like a strategic building, I don't know, you are going to measure the temperature in some place that this building is needed. So you have two options. First, that you make the transmission because the building is needed, I mean, some electricity is needed for that one. So you can ask from the TSO to make the transmission line and then distribution line to transfer electricity to that place for one building or one community, a small community. And another is that you use this wind turbine to provide the electricity for that one. Which one makes more sense for you? Do you have any idea? So you spend millions of dollars to make electricity for single life, a single building. So it doesn't make sense. So this type of technology provides some limitation, but also you should consider where you are going to use. Yeah. So any other question? I think your lunch was very good. Seems that you're getting sleepy. It doesn't work by this way. Yeah, when you don't say anything, I get stressed because it has two messages for me. You are a very good teacher, we understand very well, and you are a very bad teacher, we don't understand anything. So, yes? You said yes. You're baddest. Okay. Anyway. So, we are going to work together 2 weeks, so don't be shy and easily you can interrupt me. Yeah. So, it seems that, yeah.
Sir, regarding the renewable integration,
Mm-hmm.
we have less inertia compared to the conventional system.
Yes.
So, how to, in morning, one of your slides, you have mentioned that you worked on a project for meeting the inertia of
Yes.
20% using the renewable source.
Yes.
So, what methods will you use for that?
Should I explain all the?
No.
No, I mean basically, yeah, basically we provide the inertia from the storage devices. So we use the storage to provide the inertia. So it means that basically they said that when you increase 10% share of energy from renewable energies, you should provide 1.5% kinetic energy to keep the system balance, I mean stable. So it means that if you are going to, for example, you have a 100 kilowatt, then if you are going to increase 10%, I mean assuming 10 kilowatt, so you should provide 11.5, so 10 kilowatt electricity and 1.5 for the kinetic energy. And this kinetic energy is coming from the storage devices. But later we see that we can use the model of the synchron generator and provide the inertia from that. You want me to write the equation like this type of things? If you want, I can, but it's a little bit soon. So, any question? No, good. You're comfortable, sir? You want coffee or? Okay, no, we are friends, don't worry. Okay. So, Now, if you get back the question, did you get the answer for the question that we discussed before the lunch? How you can provide the electricity? Do you need to build a new transmission and distribution line, or you can use the local power generation? Yeah, one aspect, actually, this is not the only way, but you can also optimize the energy consumption. So, for example, instead of have the conventional thermostat for the fridge, you can actually provide the somehow program microcontroller and provide a smart control in fridge. So just give one example. So in normal situation, you have the conventional actually fridge. You see that the temperature is 2. And if it is 8 a.m., temperature is 2. If 1 p.m. is 2. I don't know, 8 p.m. is 2. And 3 midnight is also 2. Am I right? So then the problem is that we normally are in off-peak, for example, 6 a.m. We don't have too much loads. So stress over the grid is very low. And but 10 a.m., you see that lots of the companies are working and people are working with the computer in the office, and lots of other business are active, and we need lots of electricity. So it means that we are in the peak time, which stress over the grid is high. Don't worry, I'm making a joke. Then Arya, explain what did I say? Why? Okay, go and wash your face and return back. Okay, then when we reach in this time, you pay 2 times more and you increase the stress over the grid. So it is not very good from the grid perspective and from the customer perspective. Okay? So what should I do? I said that, for example, between 8 to 10 or 8 to 12, we are in on-peak. We don't, yeah. Okay. Okay. So assuming that between 1 a.m. up to 8 a.m., we are in off-peak. And from 8 a.m. up to 10 a.m., we are on peak. Okay? So I program my fridge in a way to say that, if this is 2 degree optimum degree that I need, so I said that, okay, reduce the temperature to, I don't know, -1 when we get close to 8. Okay? So, and also increase the temperature in a state of 2 to 3. Okay? So put the set point in the temperature of the fridge. So what happened? When we reach 8 a.m., the fridge will be off. Okay? Off. Then the temperature increase is coming to 2, but nothing happened because we increased the temperature degree, set point to 3. So it goes to 3. Okay? So it goes from -1 to 3 in the state of having always in 2. So from this time, 8 a.m. up to 9 a.m., 1 hour, nothing happened. Your device is off. Okay? So then we pass the 9 a.m. Now we see that, because the temperature exceed 3 degrees, then the fridge is now on. So in this on peak, we easily could actually turn off without making any problem for the consumer. So this is something that we should consider. One, minimize the consumption. We call it smart load, and you have a lots of actually technique that optimize, and it is not complicated at all. And other is that using the local power generation. So it means that we reduce stress over the grid during the peak time, and also the customer point of view is that you don't pay or you don't buy electricity during the time which the price is high. So now, do we need to build another grid? Probably no. Or we can prolong it, because after that, if you maximize the or minimize the consumption, then you can reduce 10%, and you can also increase the share of the local power generation, but it is not still enough. Then you should find a better solution. But meantime, this is actually good solution for that one. So instead of after 10 years you build another grid, probably you need 20 years. Any questions so far? Good. So you don't shy actually your bachelor, and then if something is a little bit probably need more, because you hear lots of things about the system. I don't know, smart grid, microgrid, but if you don't understand, tell me, I can actually explain. So, and now we have the concept availability. Availability means that how much your system is secure or available. So if you have actually some source of energy just based on the PV, and it's just can provide the electricity when you have 8 hours or 20 hours or 12 hours PV, it means that for 12 hours your availability is 50%. Am I right, Arya? Okay, welcome back. Okay, good. So the concept of the availability is also somehow linked with the resiliency. Does anybody know what is the resiliency? Probably you heard resilience grid, resilience building, resilience system, but nobody knows what is the resiliency. Do you know? Yes? Do you have any idea about the resiliency? Okay, so let me explain to you. So assuming that you have a PV and does anybody wants to say something? Okay. You have a PV, you have a battery in your home, and the storm happened, and you have outage. Then you said that I have a battery that can provide the electricity for me during the night for 3 hours. So it means that you have available electricity for 3 hours when the grid is off. So it means that you have a resilience grid. But then they are switched at how much this resiliency is available. So this is important. In some cases, actually, you said that, when you have a outage, it means that your system is not reliable. It is true. But it depended how long you have electricity and also outage. So when we are talking about a reliability, and when we said that the system is not reliable, it means that some peak time we have a stress over the grid, and for short time you see that you have actually flicker or this type of things that seems like a disturbance, and the system is not reliable. But when we are talking about the resilience, it means that we don't or we don't have for the longer duration. Okay? So when we are talking several hours, it means that resilient system. So is it clear for you? Arya? Good. Did you eat good lunch? You say yes. Yeah, okay, good. So This is the problem if I memorize the name and then I can easily, hey, yeah, this is target student. Okay. So now we get back to the grid. And conventional US grid availability is normally 99.9% reliable or available. So is it good or bad? Good. So, Samir, you're sleeping? Okay, so what did I say?
US grid is 99% reliable.
Mm-hmm.
Good,
So is it good or bad?
somewhat good, sir. Depending upon resilience.
Okay, so no, I'm saying 99.9 is good or bad? Good. Any other idea? You must buy chocolate for next session. Yeah. So, no. You just say yes because of this, no because of this. So, Costa, do you have any idea? Is good or bad? 99.9%. And it's good if we have 80%, yeah? Okay.
It is good without outsiders.
But when we say 99%, 99.9%, so it means that 0.1% actually we have possibility for outage. So is it good or bad? I mean, it can happen. So you cannot actually, I can say that when I'm coming here, it's probably, you know that the flight, each 1,200,000 flight, one of them fall down. Okay, so I have the possibility to, okay. So, but I can make this risk. So this 99.9 is good or bad? Tell me. You can make the risk and make the this hard operation by this? No. So it's not good. 99, even 99.9% is not good for the reliability. So what we need is 99.999. Why? Because we cannot say 100%. And it's not coming, this reliability, from conventional grid. Why? Because we have a lots of things in the power grid that can affect the other parts. So for example, a storm happening, one part, and you have actually the impacts to the other parts, because they are actually transmission lines for the long distance, and then this, it makes the system unreliable. So for example, if you get back to this, you see that a storm happened here, but we don't have electricity here. So it is very unreliable technology if you're going to make this some sensitive work and rely on this type of 99.9% reliable electricity sources. Okay? Because as long as we are caring about the human life, we cannot make any risk. So this is actually something that when we said that 99.999 is like that flight, each 1,200,000, one of them actually fall down. Yeah, Arya, do you have something? No. Okay. Yeah, and you know that this is one of the top 10 hard dying method, falling from the actually this. Yeah. Okay. So for this case, we see that now the model that we had from the Edison seems that it's not that much bad. Okay, so we didn't have transmission line, distribution line. It's close to the load center, so it is more secure. You can provide the electricity here and then do the operation here. Okay, so it means that it is more secure than the transmission line or normal grid. So look at this one. Yeah. So this can easily happening. So this is very normal in Finland. So this is why they decided to have more underground, yeah, line. And if you see in the street, you cannot find too much actually this overhead line. And this one is also, I think that normal in the warm place. I'm not sure in India, but if you go to some part of the touristic place in Turkey, you easily see that, you know, hundreds balloon over the sky. Yeah, this can easily happening. So if we get back, what we do by Nikola Tesla doesn't have such a problem, but by Edison. But what developed by Nikola Tesla has this problem. So the other part is the cost. So in Tesla's model, we need providing the substation, transmission, distribution, transformer, lots of conversion devices, but we see that, you know, here we don't need, we provide the electricity and use it. So it is not that much from here. You can use the roof or something like this, so it's much more better. And other issues with the conventional grid. It is not that much easy to interact with the new technology, like renewable energy sources. And also, it has stability problem, because we always need to provide the electricity more than the consumption, and we don't have actually too much for the flexibility because they are passive network, and we cannot actually integrate renewable. Sorry if I'm pronouncing wrong. Honestly, tell me that why it is not flexible, why we cannot connect renewable energy to the power grid, conventional power grid. You have two options. Answer my question, I buy chocolate for the old class next session. So, inertia. Yeah, why? Inertia cannot be provided, then, okay. So, why we cannot? She's going to suicide. I give the answer, she doesn't, so you're going to buy actually chocolate. Okay, tell me, why we cannot? Inertia cannot be provided. Exactly, yeah. So, the reason is that, yeah, thank you. This type of generators, they have some unpredictable dynamic behavior, can provide some disturbance for the grid, and they cannot provide the inertia for the grid. So if we increase such a generation more than 30%, then grid will be unstable. So this is why the grid code is defined in a way that you cannot integrate new generation or new types of the generation with the conventional grid. Thank you again. Okay. So, next, the grid user is a passive participant where he or she likes it or not. It means that although you can provide electricity for yourself, you cannot provide or inject to the grid. I was watching a video from a presentation, so it is not my word. This is exactly transfer of his. They said that it is like a marijuana. You can plant for yourself, but you cannot sell it for the others. Yeah. So you can electricity and use it, but you cannot sell it to the grid. So it is why they said that this is like a passive participant. And the grid is old, so the power plant is normally more than 30, so it is not compatible with the new technology. And also, beside all of these things, we have the other thing about the sustainability, availability, I don't know, cost, about the what we discuss, security and this type of issues. But the good news is that conventional power grids are extremely strong. So it is not that much sensitive. But another bad news is that now we are not living in the Edison or Tesla's duration. Technology is changing, network is changing, and we need to upgrade our system. So for this case, the technology which is connected to the power grid are not something that we use 25 or 30 years ago, or I don't know, 100 years ago. So for this case, we should provide the solution for that one. And now, what is the solution? Distributed generation technologies. This is what we are going to provide as actually solution for the jumping between the old time to modern time. So, up to now. Does anybody has any question? What? This flexibility. Which one? Yeah, it's some things that, yeah, no, basically is about the, this type of interacting with the renewable, and because when we are talking about operation is in a distribution level. And when we are talking about distribution level, that impact is the local power generation, which is not that much easy to interact with this. But this is the technology that after 2000 is growing so fast. So if we are going to consider old version of the grid, it is not somehow basically, when we are talking about the renewable energies, we have two types. It can be a small scale, less than 10 megawatt, or more than 10 megawatt. Less than 10 megawatt is distributed generation, which is distribution level. But after 10 megawatt is the power plant that can be in transmission line. Yeah. So it depended where you are going to consider. But when we are talking about the transmission line, then we have also some other constraints. So this is why now we are considering the concept of the grid forming converters, because grid forming converters can be like a voltage source that act like a master. So it can provide the reference for the other sources. But then it cannot be, it can be basically for the power plant. If you have, I don't know, 1,000 units for the PV, then it should act like a grid forming to provide the stable operating condition as a power plant. But when we go a smaller unit, less than 10 megawatt, it is between 1 kilowatt up to 10 megawatt is a distributed generation sources. So then it has the different aspect that you should consider the interaction with the distribution grid. But in power plant, you should consider the inertia of the transmission grid. This is also some other problem. Because when we are talking about the penetration of the renewable energy, it doesn't mean that local power generation. You go power plant level. So, any other question, Arya? You okay? No sleeping more? Yeah. You want me to give the break? You have a take a nap? Actually? No? It's good? Okay. No, don't worry. Any question from you is lovely, actually. Tell me.
No. So like actually, I used to get this thought
Mhm.
kind of. So like I had interest in solar energy.
Mhm.
So like there is an Thar desert region in India.
Mhm.
Like I'm not sure you know about it or not.
Mhm.
So
How
like
do you know?
it is in Rajasthan.
Mhm.
So like it is full of like as it is a desert region, it is full of sand and mostly whole of the year there is sunlight.
Mhm.
So like can there be like we can build a system like that?
Mhm.
Like we cover whole Thar desert region or maybe 50% of the region or 70% of the region, and then whatever the electricity is generated, transmit it to whole of India or maybe the whole of state, depending on whatever amount of electricity is generated.
Yes. Yes. I mean, this is a we say actually this is a some private company take care of such a generation, and it depends, but normally it's not very high level. So what happens? So assuming that you have such a potential and you provide electricity, then the owner of this small power plant provide the commitment with the or make a deal with the distribution company. So distribution company they said, okay, this is the profile that I can sell to customer. And distribution company said, okay, thank you very much, I buy these things. But can you guarantee it? Today is sunny, tomorrow can be uh,
It won't be like
yeah,
consistent.
storm for it.
Okay.
So then you promise to distribution grid, and distribution grid also distribution company promise to the customer. So if you didn't respect to your commitment, in fact, outage happening. So do you have any idea about this? What should we do? Okay. Does anybody has any idea? So assuming that I have a solar farm, I can provide the electricity and then provide this forecast to distribution company. But if I cannot provide the electricity, then distribution company cannot provide the electricity for the customer. So what should we do? This is the real case, but there are solutions for that one. So anybody wants to buy chocolate? No, wants to get chocolate? No? Battery is one option. Yeah. But let me explain you.
Diesel generator,
Diesel generator.
emergency.
Okay. But what is the benefit for you as a seller?
Because some critical loads is there.
No, I'm talking with the distribution company. I don't know what kinds of loads are appearing the others. Okay, let me tell you something. If you get back, I mean, today is the temperature is, do you have any idea what temperature? 24. So if you get back last year in this time, what was the temperature? Yeah, something like 25, 23, and the weather is quite similar, yeah? So if you get back 5 years ago, it was not -3. -3. Okay, it's like a 20, 21, or it's a little bit similar. So they check the radiation for the last 5 years, and then based on that, they